You're watching Mirror 7 News. Stay informed, stay ahead for more news.
On the night of February 13, 2023, people in northern France were treated to a sight that felt straight out of a sci-fi movie, a blazing fireball tearing through the sky. What made this one different wasn't just its brilliance, but the fact that scientists had actually spotted the asteroid, named 2023 CX-1, about 7 hours before it entered Earth's atmosphere. That kind of advance warning is rare. And what happened next has planetary defense experts rethinking how prepared we really are for future asteroid impacts. Instead of breaking apart gradually as it fell, which is what small space rocks usually do, this asteroid held firm until it reached a very low altitude, about 17 miles up, before it shattered in one massive, explosive burst. The release of energy was equivalent to about 29 tons of TNT, and almost all of its mass was vaporized in a fraction of a second. Researchers compared the effect to a bomb, a single spherical shockwave instead of a string of smaller ones. Luckily, the rock was only about the size of a beach ball, so there was no damage on the ground. But the way it broke apart is what has everyone's attention. Here's why it matters. If a larger asteroid were to behave in the same way, holding together until very low in the atmosphere, then detonating all at once, the impact on the ground could be far stronger than if it had crumbled earlier and spread out its energy. That difference could determine whether people on the ground need to evacuate, and if so, how far. The event in France reminded scientists that not all small asteroids can be considered safe just because of their size. The rock's toughness likely traces back to its origins. Samples collected after the fall showed it was an L-chondrite, one of the most common meteorite types found on Earth. Normally, familiarity might suggest predictability, but in this case, prior collisions in space may have toughened the asteroid's internal structure, making it more resistant to early breakup. Instead of falling apart bit by bit, it stayed solid until the pressure became too much, and then it exploded all at once. This isn't the first time scientists have seen such behavior. A similar event happened over Slovenia in 2020, where another asteroid lost most of its mass in a single explosion. With 2 examples now on record, researchers are beginning to worry that this could be a more common pattern than previously thought. And, since L-chondrites are so widespread, the possibility that many of them might behave this way raises the stakes for planetary defense planning. The lesson is simple but sobering. Even small asteroids can surprise us. A fireball the size of a beach ball over France didn't cause harm, but it highlighted the need for better early detection, closer study of asteroid composition, and flexible emergency response strategies. If a bigger rock with the same tough structure ever heads our way, knowing how it might break or not break could make all the difference. Stay subscribed for more videos.